Hey guys, so we're ready to start chapter 11. Yay! This is the last chapter of fifth grade, and it is on geometry. Geometry is the study of shapes and lines in math. So we have lots of things to go over. First off, let's look at some of the geometry terms and shapes that you should have learned in previous years in third and in fourth grade. So you want to remember these, okay? The first thing I have right here, this is called a line, right? So it has an arrow on both ends, and this arrow means that it goes on forever this direction, and it goes on forever in this direction. And a line is continuous. It's a continuous set of points. All right. The next one I have for you is down here, and it kind of looks like a line, but if you look on the ends, there isn't an arrow anymore. It's a dot. It's a point. Okay. And that's called an end point. So when we have end points on both sides, we call it a line segment. Okay. And segment means like a piece, right? So it's kind of like they took a piece of a line and they stopped it on both sides. This is something that we do when we want to measure how the distance of a line or the length of a line or a piece of a line. Because remember, a line up here goes endlessly in both directions. Well, when we put an end point on both sides, now we have something that we can measure. Okay, down here, look at this one. It has an endpoint on the left over here, but then it has an arrow over here on the right. Now, this is not a line segment because it would have an endpoint on both sides. Um, this one only stops here and it goes on forever in this direction. This is called a ray. Okay, kind of like a ray gun. And that's what I like to think of with this. Like when you start your ray gun, it starts here and it goes on endlessly, or your laser pointer, right? It has a ray. It starts at the laser pointer and it goes on endlessly in that direction. So this is called a ray. All right. Right here we have, let's see, we have two lines. They both have arrows on each end of the lines. And what's special about these lines is they are doing something we call running parallel. Okay, so these are parallel lines. Parallel? Maybe it's only one R. Parallel. Okay, so these are parallel lines. All right, parallel lines means that they run in the same direction endlessly, and they're never, ever, ever going to cross. Okay, so if I kept going on this line and I kept going on this line, they're never, ever going to touch each other. They stay the same distance apart all the way through. Okay, and those are parallel lines. All right, there's also something called perpendicular lines, and we see this actually right here, kind of. Um, this. Let's not call these perpendicular lines. We can call this a perpendicular line. Perpendicular line is when you have two lines intersect, and then they are making a right angle where they intersect. Okay, and that's what we have going on here. But we can actually also call this an angle because these two lines are intersecting and they create an angle in between. Actually, all three of these are angles over here. And they also kind of look like two rays meeting at the point. So here's a ray going this way, and here's a ray going this way, right? So they actually, an angle is kind of like two rays intersecting or meeting at a vertex. This is called the vertex. It's where they meet. Um, but also, if I extended this way, then we have two lines intersecting, and they create angles. Okay, so an angle is a measurement that we use to see how far these two lines ended up from each other. Let me really quick get my drawing feature going here. Yes. Okay, so this area right here is something we can measure, and when we measure that, we're measuring an angle. Okay, this one right here, this measurement is going to be kind of large, and when it's a larger measurement, when it's more than 90 degrees, we call it an obtuse angle. Okay, obtuse angle is something you should have learned last year. Yes. This one over here, when we measure this area in the middle of this angle, it's going to be a smaller number. It's going to be less than 90 degrees, and we call it an acute angle. Okay. And then the other angle I have for you over here, this is the one that I was saying is kind of like perpendicular lines, and it's perpendicular because it creates a right angle right there in the middle. All right, so we have obtuse angles bigger than 90 degrees. We have acute angles, which are smaller than 90 degrees in here. And then this right here is a right angle. And a right angle, we denote it with like a square. Ooh, I can't make it very well. There we go, like a square. We don't do the curve like we do on the obtuse angle and the right and the acute angle. We do a square, and that lets people know this is 90 degrees. It's exactly 90 degrees. So you don't even have to measure it when you see the square there in the middle. All right, so that's just a little review. That's some stuff you should already know. And if you know those things, if I was going over this just now and you're like, yeah, okay, I remember this, then you are in a good spot. So let's see what else we gotta go over. All right, so 11.1 is about polygons, and a lot of people are like, polygons? What's a polygon? I put it right here. A polygon is a closed plane figure. Okay, closed, I'm going to go over that just a second. Plane means flat. Okay, so flat figure. It's a flat shape. All right, a lot of these over here are polygons. It's a flat shape. Closed means it's not open. I'm going to show you an open shape right now. Right here. Okay. See how it's open? It doesn't close up. There's space to get out. That's not a polygon over here. Okay. Because closed means that all those lines close up. There's no way to get out. So closed, flat shape. And it's formed by 3 or more line segments. Remember, we did line segments in the last page. A line segment is a straight line, right? And it's a piece of a line, okay, that meet at points called vertices. And if you want to say one vertice, or we wouldn't say that, we would say one vertex. So singular, we call it a vertex. If there's a lot of vertexes, we don't say vertexes, we say vertices. This is plural, okay? It's a little grammar in there for you too. So what I have over here on this side of the screen, these are all polygons over here. Look at them. So we have straight line, straight line, straight line, straight line, making this shape. None of the lines are open. There's no way to get out, and it's flat. So this is a polygon, okay? Here we have another polygon, straight line, straight line, straight line, straight line, and they're all connected. There's no openings, so we have a polygon. Okay, all of the ones over on this side are polygons. Straight lines are connecting. There's no opening, and it creates this flat shape. And then just to review the vertices are where the lines meet. So this shape up here is a polygon. It has straight lines all the way around, and then they are meeting at these points. These points are the vertices. Okay, so this shape in particular has lots of points, 6 points actually. So this shape has 6 vertices. Okay, and we're going to go over that very soon also. So this side's polygons. Over here I have non-polygons. These are not polygons over here. Okay, I'm going to put that right here. Not polygons. Okay, on this side. And the reason they're not polygons, there's a few different reasons. One is these shapes have curves. Okay, remember a polygon is made of line segments. So this is not a polygon. All right, this almost looks like a rectangle over here. A rectangle is a polygon, but this one has these curved corners. This is not a vertice. Okay, it has to have the vertices, the points that they meet at. So and then this one over here we already said was open. So open shapes are not polygons. Okay, so this side is not polygons. These are all not polygons, whereas this side, these are polygons. Okay, so that's the first thing you need to know. What is a polygon? And what's the, what makes a polygon a polygon? Okay, so line segments, meeting at points, closed. Those are the most important things to remember about polygons. All right, next page. This is a table to show us some special kinds of polygons. So we can call any closed shape made of line segments a polygon, but we can also give it a more special name depending on what it has. So the first thing that should be very familiar with you is this shape right here, the first one that we have. This is a polygon. It has straight line, straight line, straight line. It's meeting at the points where the lines meet, right? So, and it's closed. So this is a polygon. But here's what happens when we have a certain number of sides, we give it a special name. So since this has 3 line segments and 3 spots where they meet at vertices, we call this one a triangle. Okay, so a triangle has 3 sides, and when we say sides, we're referring to the line segments. This is a side, this is a side, and this is a side. Okay, it actually creates 3 angles also, and those angles are right in here where the lines meet. So actually this one looks like it has a right angle right here, and then this one up here looks like it has an acute angle and an acute angle over here on the side, or on this end where the 2 lines meet. So angles, remember, are created when the 2 lines meet. So we have 3 angles inside a triangle, and that's actually where it gets its name. Tri means 3, and angle, triangle. Okay. And then vertices, remember, are the points, and I already highlighted those in yellow, and look how many there are. There are 3. Okay, so a triangle has 3 sides, 3 angles, 3 vertices. All right, you should know those. The next shape that I have here is a shape that has 4 sides. And there are lots of shapes with 4 sides. There's squares, there's rectangles, there's rhombuses and trapezoids. They all have 4 sides. But the overall arching name that we use for 4 sides is this name right here. Quad means 4. Relateral, and lateral means sides. So we say quadrilateral, quadrilateral. Try that out a couple times. That's a big word. Quadrilateral. All right, and then so quadrilateral, it has 4 sides. So we already see one line, another line, another line. There's 4 lines that make the sides. Then we have the angles. Oops, wrong pen. Okay, the angles are where those lines meet up. They create this angle measurement over here. If we had a protractor, we could measure these angles and see what their measure are. But we can also kind of see that this is acute, right? This is a smaller one. It's going to be less than 90. This is acute. And then these 2 up here look like they might be obtuse triangle or angles, right? And then so there's 4 angles. All right, and then we have the vertices next. The vertices are the points where they meet up. So there's one there, there's a point there, there's a point there, and there's a point there, right? So there's 4 vertices in a quadrilateral. Whoop. Should have typed it. Oh well. 4 sides, 4 angles, 4 vertices for quadrilateral. And a way to remember is quad means 4. If you have ever gone out dirt bike riding and you use your quad, it has 4 wheels, right? How it gets its name. All right, the next shape, or the next type of polygon, remember these are all polygons, is a pentagon. Pentagon is a shape with 5 sides. Excuse me. Okay, here's an example of one. There's many types of pentagons that can be made, but we have 1 line, another line, 3 lines, 4 lines, 5 lines that make up the pentagon. They're all straight, they all meet at points, so this is a polygon, okay? 5 sides, and then we have the angles inside, and these angles, they meet up right where 2 lines meet up. So guess what? There's going to be 5 of them. It looks like these 2 on the left are right angles. Yes, they look like corners, almost like they're going to start a rectangle or a square, and they're not. They're actually going over here into this pointy stuff. So we have pentagon. Then we have this acute angle here and this acute angle here. All right, so I found 4 angles. Where's the 5th angle? Because 4 angles is for quadrilaterals, right? Pentagon should have 5. And this angle right here is actually this. This is what we call, it's obtuse. It's an angle greater than 180 degrees. It's almost coming all the way around to a circle, but not quite because it has this area over here that doesn't complete it. But this is an angle. It's an angle larger than 180. All right, so there are 5 angles. And then the vertices, the points. So there should be 5. There's 1 point, there's 1 point, there's 1 point, there's 1 point, and then this actually inside counts as a point also. When the shape goes into itself like this, we call it concave. It's going into itself, but these still are vertices, and this measurement inside is still an angle. So don't think that because it goes inside itself, it doesn't count. It absolutely does. All right, so pentagons 5, 5, and 5. Guess what this one's going to be? Well, it didn't give us anything to start with, so we got to count how many sides. So we have 1 here on the bottom, and I'm going to just call this one 1. So we're going to go all the way around, and we're not going to count this one again, okay? So 1 side, 2, 3, 4, 5, 6 sides. 6 sides has a special name. It's called a hexagon. Hexagon. Okay, and for the angles for a hexagon, we count them on the inside. This is this measurement here. 1, 2, 3, 4, 5, 6. So there's also 6 angles, and there are also 6 vertices as well. Okay, so those are hexagons. All right, so actually, I feel like you probably should have known these 4 from 4th grade, possibly. It's definitely something that I know is in 4th grade textbooks. So hopefully you've remembered some of that from last year. But we're gonna get into some more polygons down here that are more 5th grade polygons, the ones that we learned in 5th grade. So let's get to these ones, all right? So the first one, it looks like a funny shape, doesn't it? This one is straight lines, and they're meeting at points, and it's closed. I don't see any openings. And if we count the sides, I'm going to count this one as 1, 2, 3, 4, 5, 6, 7. We have 7 sides, and a special name for a 7-sided polygon is a heptagon. Heptagon, okay? Heptagon. Hept means 7, and then we get that agon name from the polygon, right? Okay, heptagon. Angles, if we look at the inside where the 2 lines meet, they meet in 7 different spots. So there's one. Here's one of those ones that are like bigger than 180, right? Here's another one that's bigger than 180. But it's wherever 2 lines meet, they create an angle, okay? And you should have 7 spots where the 7 lines meet, right? Let's see, I think I almost found them all. There's another one, and here's one more. So 1, 2, 3, 4, 5, 6, 7, yes, 7 angles. And then also where the lines meet, they meet at points, right? So then if there's 7 angles, there's also 7 vertices. Okay, so that's a heptagon. Remember that name, heptagon. This one I think you should know also from previous years, right? Octagon, octa, like you think of octopus, and octopus have 8 arms. Well, octagons are polygons with 8 sides. And it looks kind of like one of those stop signs, right? So this should be familiar. And octagons have 8 sides. They have 8 angles. Whoop, and they have 8 vertices. They sure do. Okay, so you should be familiar with that one already. Here's a new one for 5th grade. This is a nonagon. Nonagon. So they didn't give us any numbers down here. We need to count. Let's call this left-sided line number 1. So 1 side, 2, 3, 4, 5, 6, 7, 8, 9. Okay, remember this one was 1. So there are 9 sides in a nonagon. Nonagon. That's fun to say. Okay, 9 sides. So guess what? That means that there are 9 angles. You can search for them in there if you'd like to mark them for yourself. There are also 9 vertices. It's a pattern, right? 3, 3, 3, 4, 4, 4, 5, 5, 5. It goes the same. So 9 sides makes 9 angles, and it makes 9 vertices. And we call it a nonagon, nonagon. And then this one right here, this guy is a decagon. Okay, decagon. Decagons are polygons with, let's count them, starting here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decagons have 10 sides. All right, and since they have 10 sides, they're going to meet at 10 angles, and those 10 angles are going to make 10 vertices. Okay, decagon. So the new ones I think for you are heptagon, nonagon, and maybe even decagon for some of you, right? So these are the ones that you want to kind of get in your brain and memorize. The other ones you should be already familiar with, okay? So these are special names for polygons, and it depends on how many sides, angles, and vertices they have. When you count the sides, that tells you also the angles and vertices, right? So you could just focus on counting the sides. A lot of times we say a heptagon is a 7-sided polygon. A nonagon is a 9-sided polygon, okay? All right, and they do go to more. There's an 11-sided polygon and a 12-sided polygon, right? And the polygons can have 100 sides. It's just going to be lots and lots of line segments, all right? Let's, now that we have these names in our brain, let's go ahead and talk about one more thing with polygons. So remember, the first slide was what makes a polygon, right? What's the definition of a polygon? Then we did the special names of some polygons, right? Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. And now we're going to look at what is a regular polygon. Okay, regularity in polygons depends on the sides and the angles. Okay, so we have 2 examples here. This side right here, this is a regular polygon, and what makes it regular is all sides are congruent. Congruent means same size, same measure. All right, so the sides have to be congruent to make it regular. So we got 4 centimeters here, 4 centimeters here, 4, 4, and 4. So since they're all the same measure of 4 centimeters, that's congruency. Congruency means same size, same shape, okay? And they're all lines, and they're all the same measurement. So this is congruent lines. And then the other thing that makes it regular is it has to also have congruent angles. All angles need to be the same measure, okay? And if you look at this example, all of these angles, they measured it. It was 108 degrees, 108 degrees, 108 degrees, okay? So this is a regular polygon. If I want to be more specific, since it has 5 sides, I can call this a regular pentagon, because 5 for pentagon, right? Okay. You can write the measurements to show their congruency, just like they did here. So they're showing you 4, 4, 4, 4, 4 to be congruent, and 108 angles on every single angle to show you that they are congruent. Okay. Another thing they could have done to show congruency is by marks. So congruent lines, we usually mark them with a tick mark. So we would have a tick mark on all 5 of these lines to show congruency. Instead of putting the measurements and the numbers everywhere, they put tick marks on each line segment. All right, and then that's to show congruent lines. And then to show congruent angles, they put the arcs inside. And if the arcs have the same measure, they would all have the same arc. Okay, and we're gonna look at the not polygon in just a second, and then I'm gonna show you how they mark it as not the same. So if you see these angle marks and these tick marks on the lines, that's congruency also. That's another way to show it. All right, so this is a regular polygon. Let's look at a not regular polygon. So not a regular polygon. This one right here, this is also a pentagon. 1, 2, 3, 4, 5, right? 5 lines. So pentagon, this was a pentagon. But this one's not regular, and this is why. Because remember, we needed to have all sides congruent. Well, this one does not have all sides congruent. And they didn't put measurements, but they put those tick marks I was talking about. This one right here has a 1 tick mark, and this one has a 1 tick mark. So this is telling me that this long side right here and this long side right here, they're the same, okay? They are congruent, so they're the same measurement. But look up here, this has 2 tick marks and 2 tick marks. So this means because they had to use 2 tick marks, that this line right here is the same as this one, but these two buddies are not the same as these guys down here. Okay, these are obviously, if I took a ruler, these are obviously longer, right? It's kind of like they took the pentagon over there and stretched it down, all right? But these congruency marks, you're going to see these, so you want to understand that when they put the 2 tick marks, that's kind of letting you know it's different from this one. The 1 tick mark and the 1 tick mark, those two match, but the 2 tick marks and the 2 tick marks, those don't match the other two, but they match each other, okay? And then another thing that makes a polygon not regular is the angles are different also, okay? So not all angles are congruent, and we can see that here. Okay, so it's showing you with the arcs, like I mentioned earlier, these two angles on the bottom, they have single arc, right? So these two are the same. But then we do the same thing. If we find another angle later on that's not the same as the other guys, we have to mark it differently. And so we put double arcs. So see how this guy has double arcs and this one has double arcs. So that means these two are the same to each other, but these two are not the same as these two. Okay? Some of you might be wondering, well, why didn't they mark this angle up here, and why didn't they mark this line down here? Well, that's because they didn't pair up with anything else, right? Nothing else matched this one, so they just kind of left it. It was just alone. It didn't have any congruency with another angle, so it's just left alone. These marks that we use are for congruency. And so if it's single marks, those two are congruent. If it's double marks, those two are congruent. But if it doesn't have anything congruent with it, we just don't mark it. All right? All right, so you should know how to identify a polygon. You should know the special names of polygons. And now you should know if a polygon is regular or not regular. And that is lesson 1. That's a lot of stuff, but that is lesson 1. And we should now be able to do some of the practice. Okay, so the instructions say, oh, I cut off the instructions. Well, the instructions said, name the polygon. So we got to name it. And we're not just going to say polygon, right? We're going to use those special names that we learned earlier. And then we also have to say if it's regular or not regular. And that's it. All right. I'm going to use my typer. So let's check out this guy. This number 2. How many sides does it have? That's how we get its name, right? The sides. So I'm going to start at the bottom. So this is 1, 2, 3, 4, 5, 6 sides. So who remembers the name of the 6 sides? 6-sided polygon is a hexagon. Oh, I'm still in caps. Hexagon, right? Now, what about the other part? The second part was, is it regular or not regular? So remember, for a polygon to be regular, it has to have congruent sides and congruent angles. And I see tick marks on all 6 sides, so that's good. That means congruent sides. And I also see arcs in all 6 angles, so this is regular. Okay, regular hexagon. You could say hexagon regular, or you could say regular hexagon. I think on the practice in a little bit, I put regular in the front, but just, yeah. Okay, so regular hexagon there. How about this guy? Let's go over here. First, let's count the sides to name it. So we got 1 on the bottom, 2, 3, 4. 4 sides. Now, some of you are going to want to call this a rectangle. It is a rectangle. You're not wrong. But I want you to use the names that we used on the previous slide. So quadrilateral is what we're going to use for this one. Quadrilateral is 4-sided polygon, right? And then let's see if it's regular or not. Well, I see single tick and single tick on the top and bottom lines, but then I see double ticks. And so those double ticks, remember, mean that those are not the same as the other two. So these are not all 4 the same size. So if they're not all four the same size, then we need to say, oops, wait a minute, get me back in there. We need to say not regular. There we go. Okay. Let's do another. So if we start at the bottom, let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides is an octagon. Octagon. There we go. And then the next part, is it regular or not regular? And we look at the markings, right? So regular, same size, same sides and same angles, and I see single ticks all the way around, and I see single arcs all the way around, so this is regular. Oops. Okay. Are we good? So there's a few more down here. These ones are meant to be on your own. Okay, take a look at them, maybe pause the video and try solving those. What do you see? Are these regular? Are they not regular? Are they triangles? Are they octagons? Are they heptagons? What are they? All right, if you need to go back to back in the video, you can go up to the other slides from the video as well. And good luck.